In this videotape, we're going to look at some sets of numbers and their graphs, and we're going to review the distributive law and the idea of order of operations by using them to help us to simplify algebraic expressions. Let's start with the following problem. If A, and we're using capital A to represent a set, is the set of all numbers x such that, this line is read such that, x is an odd factor of 15 that is greater than 1, and if B is the set of all numbers y such that y is a prime number between 1 and 15, or the greater than 1 and less than 15, strictly between 1 and 15, then I want you to list A intersect B, list the elements in that set, the intersection, and also find A union B. So find all elements in the intersection and in the union of these two sets. Okay, let's first list all the numbers in set A and in set B. Set A is the set of all numbers x such that x is an odd factor of 15 that is greater than 1. Okay. Let's look at odd numbers greater than 1 that could possibly be factors of 15. Greater than 1, next would come 3, 5. I'm just writing down all the odd numbers. 7, 9, 11, 13, 15. An odd factor, now we want, these are odd numbers that are greater than 1 that could be factors of 15. Now which are the factors of 15? 3 is a factor of 15. 3 divides 15 evenly. 5 is a factor of 15. 7 does not go evenly into 15, neither does 9, 11, 13, 15 is also a factor of 15. So set A consists of the numbers 3, 5, and 15. Notice we can write a set either in this manner with the braces, and we actually list the elements in the set, numbers 3, 5, and 15, or we can write the set A in this manner here. It is all numbers x such that, and then write a descriptive phrase about x. In other words, x is an odd factor of 15 that is greater than 1. Okay, let us now write down the elements of set B. All numbers y, such that y is a prime number between 1 and 15, greater than 1 and less than 15. Let's start writing down the prime numbers. Well, 2 is a prime number, 3. Now, we won't worry about any other even numbers because every even number other than 2 has 2 as a factor and therefore is not prime. So we have 3, 5, 7. Now 9 is odd, but it's not prime because 3 is a factor. Then comes 11, 13. 2, 3, 5, 7, 11, 13 are the elements in set B. These are the prime numbers between 1 and 15. 2, and then we excluded all the other even numbers, 3, 5, 7, we excluded 9, 11, 13, and we wanted, and of course 15 we exclude. Okay, now we're ready to list the elements in the intersection and in the union of these two sets. The intersection consists of every number that is both in set A and in set B. A intersect B is the set of all numbers that are in set A and also in set B, that are common to both sets. So which numbers are in both sets A and B? 2 isn't. Well, let's do it this way. 3 is in both, 5 is in both, 15 isn't. So the only overlap would be on the numbers 3 and 5. The union of two sets is the set of all numbers that are either in set A or in set B or in both. So here we will write for the union 2, 3, 5, 7, 11, 13, and 15. We have the 3, 5, and 15 that are present in A, and the 2, 3, 5, 7, 11, 13 that are present in B. So here we have the intersection of these two sets and the union of the two sets. In the next problem, I want you to determine whether the given statement is true or false. Determine whether each statement is true or false. The first one. The square root of 9, which means the positive square root of 9, is an element of set n. N represents the set of natural numbers, the counting numbers, the positive integers, 1, 2, 3, 4, and so on. The square root of 9, the positive square root of 9, is 3. This is true because 3 is a natural number. In part B, 2/5 is an element of set Z. True or false? Well, Z represents the set of integers. 0, plus and minus 1, plus and minus 2, plus and minus 3, and so on. 2/5 is not an integer. 2/5 is a rational number. It's the quotient of two integers, but it is not an integer. Therefore, this is a false statement. 2/5 is not an integer. And the last statement, 5 is an element of set Q. Q represents the set of rational numbers. Is 5 a rational number? A rational number is a number that can be expressed as the quotient of two integers. 5 can be written as 5 over 1, the quotient of two integers, and therefore this statement is true. Every integer can be expressed as a quotient of two integers, just put a 1 downstairs, and therefore it's a rational number. Of course, not all rational numbers are integers. 2/5 was a rational number that was not an integer. 5 is a rational number, but it's also an integer. So the last one, 5, is a rational number. It's an integer, but it's a rational number as well. In question 3, I want you to graph the following sets on the real number line. The first one, the set of all numbers x such that x is less than or equal to 2. Here we have our real number line. This is 0, 1, 2. This would be -1, -2, and so on. We want the set of all numbers x such that x is less than or equal to 2. Okay? The equal to 2 would be here. And we want also less than 2. Now, this should be filled in. If it was just less than 2, this would be an open circle. Because it says less than or equal to 2, it's filled in. Actually, we should be drawing this right on the number line. But since most of you are going to be watching this on black and white monitors, I am drawing it a little above the line so that you can see it clearly. But in the book, you will notice that the graph is drawn directly on the number line. X less than or equal to 2. Okay, in part B, the set of all x such that -4 is less than x is less than or equal to 1. I want all x values between -4 and 1, excluding -4, but including the right endpoint of 1. Here is my number line. 0, -1, -2, -3, -4, 1, 2, 3, 4. To get a feeling for what's going on, we want all numbers between -4 and 1. Well, between -4 and 1, we would indicate this way. This would be strictly between -4 and 1. However, we want to include 1, the right endpoint, and exclude the -4. This means all numbers greater than -4 and less than or equal to 1. From -4 to 1 with the -4 excluded, but the 1 included. And once again, this should, strictly speaking, be drawn on the number line. And in part C, all numbers x such that x is greater than -3. Here's our number line. 0, -1, -2, -3. Greater than -3, we would indicate in this manner. If it was greater than or equal to -3, it would be filled in. This means greater, strictly greater than -3. And then moving off to the right there. Question 4. Are the following statements true or false? Justify your answers. The first statement, A times B plus C in parentheses equals AB plus C. Okay, is this statement true or false? Well, to those of you who are familiar with the distributive law, you realize right away that this is incorrect because A times B plus C should be written as A times B plus A times C. A should be distributed through the parentheses, A times B plus A times C. So you would believe that this would be false. If you weren't sure, let's say you didn't know about the distributive law, what you could do is pick a few values for A, B, and C. For example, we could let A equal 3, B equals 1, and C equals 2, and see if this works. Now, if it works, it doesn't make it true, but if it doesn't work, then for sure it is false. Let's try this out. Letting A be 3, B be 1, and C be 2, 3 times 1 plus 2 should be equal to 3 times 1 plus 2. Well, 3 times 1 plus 2 is 3 times 3, and that should be equal to 3 plus 2, and 9, of course, is not equal to 5, and therefore this is false. Now, if this had worked out, that would not mean that this is necessarily true, but if it doesn't work, then for sure it is false. And we knew this, in fact, in the beginning because we know what the distributive law says. It's A times B plus A times C. In the second part of this problem, let's look at the following. The statement is A plus B in parentheses plus C is equal to C plus A plus B. We want to know if this is true or false. Well, this is true because of the commutative property of addition. Addition is commutative. A plus B, and we add C to it, is the same as C and add A plus B to it. And if you wanted to get a feeling for what this was saying, once again, you could let A be 3, B be 1, C be 2. I just picked, 3 numbers, and see what we get. 3 plus 1, in parentheses, plus 2 should be equal to 2 plus 3 plus 1, or 4 plus 2 should be equal to 2 plus 4. And of course, this is true, as I said, because addition is commutative. Okay. In question 5, I want you to evaluate the following expressions. In part A, minus 5 minus, in parentheses, a minus 3, plus, in parentheses, a minus 2, minus, in parentheses, a minus 8. Okay. We're adding and subtracting sign numbers here. Minus 5, instead of subtracting a minus 3, we add the opposite, so we're adding a plus 3. We're adding a minus 2, and instead of subtracting a minus 8, we'll be adding the opposite. So we have really minus 5 and a plus 3 and a minus 2 and a plus 8. Adding the like signs, minus 5 and the minus 2, that's a minus 7. And plus 3 and plus 8, that's plus 11. And now adding the unlike signs, minus 7 and a plus 11, gives us an answer of plus 4. The second part, minus 6 in parentheses squared minus the product of 4, minus 2, and minus 5. All right, minus 6 squared is plus 36. And subtract the product that we have here. Remember, multiplications and divisions precede additions and subtractions according to order of operations. Well, 4 times minus 2 is minus 8 times minus 5 is plus 40. So we have plus 36. Subtracting a plus 40, that's plus 36, and then add the opposite, add a minus 40, plus 36 and a minus 40 for an answer of minus 4. In part C, we have the following. 7 minus 3, then in parentheses 2 minus 4. Order of operations dictates that first we handle anything that's in a grouping symbol, then multiplications and divisions precede additions and subtractions. So 7 minus 3, 2 minus 4 gives you a minus 2. The multiplication is to precede the subtraction. So you don't say 7 minus 3 is 4, but rather you say minus 3 times a minus 2 is plus 6. 7 and a plus 6 gives us a plus 13. You can think of this as plus a minus 3 times 2 minus 4. So adding a minus 3 times a minus 2, we're adding a plus 6. Notice the difference between this problem and the following. 7 minus 3 in parentheses times 2 minus 4 in parentheses. If you want this subtraction to occur in this manner, you have to put it in parentheses because the multiplication will precede the subtraction unless the grouping symbol changes the order of the operations. So first we handle what's in the grouping symbol. 7 minus 3 is plus 4. 2 times minus 4. 2 minus 4 is a minus 2. 7 minus 3, that's plus 4. 2 minus 4, that's minus 2. And now the multiplication, 4 times minus 2 is a minus 8. So in this form here, you do not do the subtraction until after you've done this and the multiplication. And then you either subtract 3 times that or add the minus 3 times it. Here, however, you do this subtraction, and then the multiplication. Okay, in problem E, we have the following. The absolute value of 7 minus 9. Subtract now from that the absolute value of 2 minus 3. This is the absolute value of 7 minus 9, that's minus 2, minus the absolute value of 2 minus 3. Well, 2 minus 3 is minus 1. We need the absolute value of that. The absolute value of minus 2 is plus 2, minus the absolute value of minus 1 is plus 1. 2 minus 1 gives us an answer of 1. So the answer is plus 1. In the next part, part F, we have the following. Minus 9 minus, in brackets, 3 minus 8 times, in parentheses, 4 minus 2. Close parentheses, close brackets. Order of operations dictates we handle what's in the grouping symbols first, always proceeding from the innermost first. So we rewrite this as minus 9 minus 3 minus 8. Let's handle what's in this. 4 minus 2, that's a 2. Minus 9 minus 3 minus 16. The multiplication precedes the subtraction. Equals minus 9 minus now. 3 plus 3, take away a plus 16, it's plus 3. And a minus 16, and that's a minus 13. Minus 9 minus a minus 13 is minus 9 and a plus 13 for an answer of plus 4. In problem G, we have the following. 2 times 3 minus 6 in parentheses, minus 6 times 4 minus 5 in parentheses, divided by minus 5 times minus 1 minus 3. All right, what's in the grouping symbol? So 2 times 3 minus 6 is a minus 3. Minus 6 times 4 minus 5, that's a minus 1. Over minus 5 times minus 1, that's plus 5, minus 3. That gives us minus 6 plus 6 over 2. Minus 6 and a plus 6, that's 0, divided by 2, and the result is 0. I want to remind you how division works. If I have, for example, 12 divided by 3, I write down the answer is 4, since 3 times 4 equals 12. 0 divided by 2 is 0, similarly, since 2 times 0 is 0. 3 times 4 gives you 12. 2 times 0 is 0. A 0 upstairs is no problem. If, however, this should come out to be, say, 2 over 0, this would not be defined. It would be meaningless. This is undefined or meaningless. Because if I were to give it a meaning, let's say I give it whatever I put in that box. Well, whatever I would put in that box would have to work out that 0 times what's in that box would have to be equal to 2. Now, there's nothing that I can put into that box, which when I multiply by 0 would give me 2. Therefore, this is meaningless. I can't put anything into this box. So 2 divided by 0, undefined or meaningless. However, 0 divided by 2 is perfectly okay. 0 divided by 2 is 0. There's no difficulty with that. A 0 downstairs causes trouble. A 0 upstairs does not. In problem 6, I want you to evaluate the following. Given that x equals minus 3 and y equals plus 2. The first thing I want you to evaluate is x plus y minus, in parentheses, x minus y. All right, what I'm going to do is substitute in for everything all the x's minus 3 and for all the y's plus 2. Minus 3 and a plus 2. Here a minus 3 minus a plus 2. Well, minus 3 and a plus 2, that gives us minus 1. Minus 3 minus a plus 2 is the same as adding a minus 2, so minus 3 and minus 2, that's minus 5. Minus 1, instead of subtracting a minus 5, we add a plus 5. And we get an answer of plus 4. In problem B, x squared minus y squared over x squared plus y squared is to be evaluated. Once again, x is still minus 3, y is plus 2. First go through letting x be minus 3 and y being plus 2. Minus 3 squared minus a plus 2 squared over minus 3 squared plus a plus 2 squared. Minus 3 squared is plus 9 minus a plus 4 over plus 9 and a plus 4. Well, plus 9, take away plus 4, that's plus 5. 9 plus 4 is 13, so our final answer is 5/13. In problem C, x minus y cubed. We want x, which is minus 3, minus y, which is plus 2, quantity cubed. Well, first, minus 3 minus a plus 2 is minus 3, and the minus 2, that's minus 5. Minus 5 cubed means minus 5 times minus 5 times minus 5. The result will be minus 125. In problem 7, I want you to simplify various algebraic expressions, making use of distributive law and order of operations. In part A, we have x plus y in parentheses minus x minus y in parentheses. All right? When you're subtracting this, you're really distributing a minus 1 through the parentheses. So it's x plus y. Minus 1 times x is minus x. Minus 1 times minus y is plus y. Combining now the like terms, x and minus x cancel each other out. Y plus y gives us 2y. By the way, if you look back to problem 6a over here, we had the same idea, x plus y minus x minus y, and we actually substituted in for x and for y. Our final answer that we got plus 4 is the same as 2y. Whereas this does simplify, the x's do cancel, this simplifies to 2y, and if you knew that, well then 2y does come out to be plus 4. Here we were simplifying first. And then if you wanted to plug in, say, y equals 2, you could have. Okay, let's do problem B. 3a minus 4 times a minus 1 in parentheses, minus in parentheses 5 minus a. Here we have 3a. Here minus 4 is to be distributed through the parentheses. Minus 4 times a, that's minus 4a. Minus 4 times minus 1 is plus 4. Here, minus means minus 1 is to be distributed through the parentheses. Minus 1 times 5 is minus 5. Minus 1 times minus a is plus a. Combining now the like terms, we have 3a plus a, that's 4a, minus 4a. So the a terms cancel out, the 3a and the a, 4a and the minus 4a, leaving us with plus 4 and a minus 5 for an answer of minus 1. In problem C, we have the following to simplify. 4rs times r minus s in parentheses minus 6 times rs squared minus r squared s in parentheses. Distributing the 4rs through the parentheses. 4rs times r is 4r squared s minus 4rs times s, so minus 4rs squared. Now distributing the minus 6 through the parentheses, minus 6rs squared, and then minus 6 times minus r squared s is plus 6r squared s. Combining like terms, we have a 4r squared s and a 6r squared s to give us 10r squared s. And we have a minus 4rs squared and a minus 6rs squared to give us minus 10rs squared. And we can stop there. In problem D, we have the following. 6a minus, in braces, 2 plus 3 times, open brackets, b minus, in parentheses, a minus 2b, close parentheses, close bracket, close braces. Okay, we're going to work from the innermost grouping symbols out. So here I'm just going to rewrite until I get to the innermost grouping symbol. 6a minus, in braces, 2 plus 3, bracket. Now, b minus, I'm going to think of this as minus 1 to be distributed through the parentheses here, minus 1 times a, minus 1 times minus 2b, that's plus 2b. So I've eliminated the parentheses. 6a minus, braces, 2 plus 3. I'm going to try to simplify what's in the brackets here. We have b plus 2b, that's 3b minus a. 6a minus, braces, 2 plus, now 3 is to be distributed through these brackets here. 3 times 3b, that's 9b. 3 times minus a, that's minus 3a. So we don't have the brackets anymore. 6a minus. Now, instead of just minus what we have here in the braces, think of this as minus 1 to be distributed through the braces. Minus 1 times 2 is minus 2. Minus 1 times 9b is minus 9b. Minus 1 times minus 3a is plus 3a. Combining now like terms, 6a plus 3a, that's 9a, minus 9b minus 2. And there we have our final answer, 9a minus 9b minus 2. All right, in problem 8, I want you to translate each of the following sentences into algebraic form. Translate each of the following sentences into algebraic form. By the way, this will be the last problem on our videotape. In part A, we have the following sentence. 3 less than the product of 2 numbers is 4 more than their sum. Three less than the product of 2 numbers is 4 more than their sum. I'm going to let x and y represent the 2 numbers. Okay, 3 less than the product of 2 numbers. Well, the product of the 2 numbers is x times y. 3 less than the product of 2 numbers is x, y minus 3. 3 less than the product of 2 numbers is translated as an equal sign. 4 more than their sum. 4 more than the sum. 3 less than the product of 2 numbers is or equals 4 more than their sum. So this sentence translated into this equation. And finally, in part B, the square of the sum of 2 numbers is 12 more than the sum of the squares of the two numbers. The square of the sum of two numbers is 12 more than the sum of the squares of the two numbers. Once again, let x and y be the numbers. The square of the sum of two numbers. The square of the sum. Here is the sum. Here is the square of the sum of two numbers is equals 12 more than the sum of the squares of the two numbers. The square of the sum of the two numbers is equals 12 more than the sum of the squares. And that brings us to the end of this tape.